In this part 1 video, and in the next part 2 video, we study two foundational models of economic growth, the Harrod-Domar model and the Solow Growth Model. Instead of studying them separately, we will develop both models side by side, step by step. To understand why Harrod-Domar predicts instability, while the Solow model predicts convergence. Let Y of t and K of t denote total output and total capital stock of an economy at time t, both measured in units of currency. Both of these aggregate macroeconomic variables change over time. In discrete time, we write delta Y, which means output today minus output yesterday. Similarly, delta K represents the change in capital stock over a discrete period. In the economics literature on growth theory, we typically study these changes in continuous time, which enables us to use calculus. We write y dot to represent the derivative of output with respect to time, and k dot for the derivative of capital. These represent instantaneous rates of change of output and capital. In contrast, delta measures represent changes in discrete time. However, for sufficiently small time intervals, these two ideas are mathematically equivalent. To study growth, we focus on relative change. We therefore divide y dot by y. This gives the growth rate of output. Similarly, k dot divided by k gives the growth rate of capital. When multiplied by 100, these ratios become percentage growth rates of output and capital. These growth rates form the foundation of all growth theory. Both Harrod-Domar and Solow begin from the same fundamental accounting identity. The change in the capital stock per year equals new investment per year, minus capital that wears out per year. The lowercase letter s and the Greek letter delta represent the annual saving rate out of national income, and the depreciation rate of wear and tear of the national capital stock. The saving rate S here is the fraction of national income that is saved and invested each year. It should not be confused with the marginal propensity to save, which is a short-run behavioral concept measuring how saving responds to changes in disposable income. The basic idea is the same in both models. Capital accumulation is central to economic growth. Capital increases through saving and investment, and decreases through depreciation. The change in capital equals saving times output, minus depreciation of the existing capital stock. Up to this point, both models are identical. From this common starting point, however, the two models diverge sharply, because they explain economic growth using very different mechanisms.
Now comes the crucial difference. This difference revolves around the relationship between national output and the inputs used to produce that output. The two models consider different sets of productive inputs as responsible for the production of national output. The Harrod-Domar model effectively assumes a very simple production structure, in which output depends only on capital, while labor and technology are taken as fixed or ignored. This assumption implies a fixed capital output ratio and no scope for substitution between factors of production. As we will see, this simple production structure plays a central role in making the Harrod-Domar model unstable and divergent whenever the economy deviates from its warranted growth path. The Solow model modifies this structure by explicitly incorporating labor and technology as additional inputs in production. This richer production framework introduces adjustment mechanisms that allow the economy to respond to disequilibrium, making the Solow model stable and convergent. We now formalize these ideas using equations. The first and most important parameter to discuss is the capital output ratio. It is defined as the current capital stock divided by the current annual output of the economy. For example, if this ratio equals 4, it means the existing capital stock is equal to 4 times the economy's current annual output, or 4 times its gross domestic product, GDP. The Harrod-Domar model assumes this capital output ratio is fixed. Output is proportional to capital, there is no substitution between labor and capital, and technology is implicit and fixed. Because of this proportionality, Harrod-Domar treats the capital output ratio as constant over time. To derive the growth rate of capital, we begin with the capital accumulation identity. Dividing this identity by the capital stock, and using simple algebra, we obtain the capital growth rate as the saving rate divided by the capital output ratio, minus the depreciation rate. Next, using the fixed capital output ratio, we can write output as capital divided by the capital output ratio. Differentiating with respect to time shows that the change in output is proportional to the change in capital. Dividing both sides by output, we see that in the Harrod-Domar model, the growth rate of output is exactly equal to the growth rate of capital. Since capital growth equals saving rate divided by the capital output ratio minus depreciation, output growth must equal the same expression. For simplicity, Harrod often sets the depreciation rate equal to 0, while Domar sometimes keeps it. As a result, the growth rate in the Harrod-Domar model is conventionally written as the saving rate divided by the capital output ratio.
If we represent the change in output as a derivative and use it in the growth rate equation we just derived, we obtain a differential equation that describes output growth. By separating variables and integrating both sides with respect to time, we obtain the solution for national output in the Harrod-Domar model. Exponentiating the result gives output as an exponential function of time. For numerical example, let the saving rate be 20%, the capital output ratio equal 4, and the initial level of output equal 1 unit of currency. Using these values, the warranted growth rate of output equals saving divided by the capital output ratio, which is 0.05, or 5% per year in continuous time. This means national output grows exponentially at a constant instantaneous rate of 5% per year. The resulting output function is shown in the diagram. The exponential growth path is called the warranted growth path. This path implies, for example, that output grows by about 65% in 10 years. This is shown by the highlighted point on the curve, and it is confirmed numerically by evaluating the output function at time 10, where output equals approximately 1.65 units of currency. If actual growth equals the warranted growth rate, the economy stays exactly on this growth path. However, if actual growth is even slightly higher, due to a small change in the saving rate or the capital output ratio, output diverges upward away from the warranted path, as shown by the higher curve. If actual growth is slightly lower, output diverges downward away from the warranted path, as shown by the lower curve. There is no stabilizing force that pushes the economy back to the warranted growth path. This property of the Harrod-Domar model is known as knife edge instability. In the next part 2 video we'll focus on the Solow Growth Model in the similar manner and compare the results with the Harrod-Domar model.